Hello, my name is Raul Cano. I'm a team member in Group 1, and this is our class diagram. The attributes are represented with the minus sign before the attribute name, and data types are implied, like string, integer, or date. Methods are represented with a plus sign, and for the museum class, the attributes are museum ID, an integer representing a unique identifier for each museum, name, a string representing the name of the museum, location, a string indicating location of the museum, description, a string describing the museum, and exhibits, a list of exhibits associated with the museum. And the methods are add exhibit or remove exhibit or get exhibit. For the exhibit class, attributes are exhibit ID, an integer representing a unique identifier for each exhibit, title, a string representing the title of the exhibit, description, a string describing the exhibit, date created, a date object indicating when the exhibit was created, and type, a string indicating the type of the exhibit, artifacts, a list of artifacts associated with the exhibit. Methods are add artifact, remove artifact, get artifacts. And for the artifact class, attributes are artifact ID, an integer representing a unique identifier for each artifact, name, a string representing the name of the artifact, date acquired, a date object indicating when the artifact was acquired, type, a string indicating the type of artifact, image URL, a string representing the URL for artifact's image, exhibit, a reference to exhibit to which artifact belongs, categories, a list of categories to which the artifact belongs, tags, a list of tags associated with the artifact, methods is update description, get image, get details. And for category class, the attributes are category ID and integer representing a unique identifier for each category. Name is string representing the name of the category, artifacts of this artifacts associated with the category. Methods is add artifact, remove artifact, and get artifacts. The tag class, the attributes are tag ID and integer representing a unique identifier for each tag. Name is string representing the name of the tag, artifacts of this artifacts associated with the tag. Methods are add artifact, remove artifact, get associated artifacts. And for the user class, attributes are user ID and integer representing unique identifier for each user. Username, a string representing the username of the user. Password, a string representing the password of the user. Email, a string representing the email address of the user. First name, a string representing the first name of the user. Last name, a string representing the last name of the user. Methods are register, login, which includes username, password, search artifacts, view exhibits, and view artifact details. And for the admin class, attributes are admin ID and integer representing a unique identifier for each admin. Username, a string representing the username of the admin. Password, a string representing the password of the admin. Email, a string representing the email address of the admin. Methods are add exhibit, remove exhibit, update exhibit, approve artifact, remove artifact, add admin, remove admin, or view pending approvals. And thank you.
Hello, my name is Alexander Ostrina. I'm the project manager for the group LARC, and this is our database schema. Starting with the admin, we'll have the admin ID slash email, which will be a variable character, which means it can be a character, an integer, or a special character. The password will also be a varchar. Next, we'll have the employee, which will have an employee ID, which will be a varchar. The first name being a character, last name being a character, and the password being a varchar. Next we have the users, the user ID slash email, which will be varchar, their first name being a character, last name being a character, password being a varchar. For the guest users, they'll just have a default login, which will be a varchar. And then the search will have the user inquiry, which will be a varchar if they accidentally put a special character or number. And they'll have the time of search, which will be stored as date and time. We'll have a review with the user ID, which will be a varchar. We'll have the contents, which will be a character, and I'll have the rating as an integer, and I'll have the date and time in which the review was made. We'll have the video, have the video ID as an integer, I'll have the date and when that video was uploaded. We'll have text as text ID. It will be stored as an integer. I'll have the date of which that text was uploaded and the contents of the text as a varchar. Then we'll have the images as an image ID. This will be stored in an integer. I'll have the contents as a varchar and the date the image was uploaded. Next, we have the PDF. PDF ID as an integer and the date in which the PDF was uploaded.
Hi everyone, this is Karen Villablanca and this is our package diagram. And in our package diagram, it consists of 4 subsystems. The user and data management subsystem contains 2 classes, which is the admin and the editor. The admin and the editor classes have an axis stereotype pointing towards the database management subsystem, which means that they have access to database functionalities for managing related data. The database management subsystem contains 2 classes, the local database and the cloud database. And there is a synchronization relationship or dependency with the sync dashed arrow or line between the local database and cloud database. This indicates that they are synchronized and will be sharing data between them. The import stereotype goes from the database management package towards the collection management package. This means that the database management subsystem imports or provides data to the collection management subsystem. The collection management subsystem has 2 classes, the records and artifacts, and it also has the use stereotype arrow that points toward the user interaction subsystem, showing that the collection management subsystem is used by the user interaction subsystem. And this indicates that the records, artifacts, or other collection information are being viewed or interacted with by readers. Thank you.
Hello, Luke Somerset of Group Lark here once again. I'll be showcasing our database prototype, which consists of the main screen of the local app. Here's the prototype UI. It is a rough draft of what the program will look like. There would be several visual changes to come, since this mockup was made using a Microsoft Windows form, and the program is intended to run on Apple systems. The largest element here is the box containing a list of item records. There are 6 columns describing each item record: the item's number, name, category, description, location, and status. There are 2 example entries here. The client suggested the idea of each element having a text wrap feature, which allows the entirety of the field to be viewed even if it is too long for the column. When a row is double-clicked, it would open a new window showing the corresponding item record in full. The user would be able to organize the list here by any of these 6 fields, either in ascending or descending order. When highlighted, an item record will throw its first picture into the item preview box in the lower left of the window. Above the item preview box is the directory. Here, the user can filter the list by a category hierarchy, restricting shown items to whatever category the user has chosen. All data would be shown here, including user data and template data, for example. In the upper left is the menu bar. More controls may be added in the future, but each menu has a list of commands. Some commands may require an item record to be highlighted to be selectable. File contains some database-level commands, such as Cloud Sync and user settings. Edit houses several expected features, such as undo, redo, global search, etc. View will allow users to show or hide different elements on the screen, such as the directory or item preview. Records houses options relating to item records, such as creating, editing, or deleting records. Tools will allow users options to generate data based on the database, such as graphs or singular record summaries. Help allows the user to access the manual or the online help page. Finally, in the upper right are the search controls. There is a text box for the user to enter a string. The search button will search for the provided string. The Advanced Search button will bring up a new window allowing more specific search specifications. Future plans would include creating new windows or window layouts for more detailed viewing or editing of database entries, advanced searches, and other required functions.